Good morning, dear kids. Today I'm taking your your chapter 1, exercise 1.2. Your first problem is express each number as a product of its prime factors. You have 140 and prime factors, you have to find it out like this. So you got the prime factors as 2, 2, 5, 7. So you have to just write it like this. That is how you find the prime factors, and I think the complete set will become easy. So that will be your homework. Can you do that? Yes, very good. Next we have find the HCF and LCM of the following pairs of integers and verify that LCM into HCF is the product of two numbers. You know very well that HCF and LCM हम कैसे find करते हैं, ठीक है? Now we have 26 and 91. So you have to first find the HCF and your LCM of both the numbers. HCF is the highest common factor and LCM you have to take common as well as uncommon factors. Okay. So if you get 26 and 91, their HCF will be 13 if you find it out. And their LCM will be 182. Yes, you can find it out, no problem. Now you have to guess, now you have to find whether the product of LCM and HCF is equal to the product of two numbers. You have to verify that. So you have HCF in hand, LCM in hand, and the two numbers in hand. You have to take the product of HCF into LCM and find out what number you are getting. I guess the product of HCF and LCM is 2366. And you have to take product of the two numbers given. Which are the two numbers given? 26 and 91. And for that also the product will be 2366. So once you got both the product, you can say hence verified. What you have verified? That HCF and LCM ka product is equal to product of two numbers. Similarly, you can go for your second and third. In your question number 3, they have asked find the LCM and HCF of the following integers by applying prime factorization method. So you have your numbers as 12, 15 and 21. Yes, you have to get the prime factors. Prime factors of 12 are 2, 2, 3, and for 15 you have 3 and 5. For 21 you have 3 and 7. So what is the HCF, my dear kids? The HCF is the common factor. What is the common factor in all? It is 3. So the HCF is 3. How you will get the LCM? LCM you have to take common as well as your uncommon factor will be your LCM. So what will be the LCM? Common factor is 3. And which are the uncommon factors? 2, 2, 5, 7. So you have to write them all. And your final answer will be 420. So that's your LCM. Similarly, you have to find, you have to find the HCF and LCM of your next two. Will that be easy? Your next is the HCF of two numbers is given as 9. And you have to find LCM of these two numbers. My dear kids, we know very well HCF into LCM is equal to product of two numbers. So the two numbers are 306 and 657. HCF is given to you as 9 and you have to find LCM. How you will find LCM? Something like this. Take this 9 over here. And your final answer, you have to get it. That will be your LCM. Your next topic for today is, without actually performing the long division, state whether the following rational numbers will have a terminating decimal or non-terminating decimal. What do you mean by terminating, which has a finite number, set of numbers? And what is non-terminating, which has an infinite set of numbers? So if I'm giving you an answer of 1.67, so that is your terminating decimal. But what is non-terminating, repeating? If I give you something like this, so this is non-terminating repeating number. So how you will get it from a fraction? Suppose if I give you 13 upon 3125. So how you will get it that this is a term, after dividing 13 by 3125, I'll get a number which will be terminating or which will be non-terminating. How I'll get it? So for that, you have a denominator 3125. You have to factorize the denominator. After factorizing the denominator, prime factors. How you'll find the prime factors, you know very well. So you will notice that I'm multiplying 5 for 5 times and I'm getting 3125. So the denominator can be written as 5 for 5 times. Okay, so this will be your terminating decimal expansion. So first you have to factorize your denominator, and if your denominator has only factors in the form of 2 and 5, remember 2 and 5 only. If only 5 will also work, only 2 will also work, and together 2 and 5 as a factors are there in the denominator, then such kind of fractions will be called as terminating fractions. Clear? Shall we give a try? So this is your terminating fraction, your first one. Shall we give a try for one more? Yes, let's give a try for our sixth problem. Now sixth problem, as it is, the denominator is 2 raised to 3 and 5 raised to 2. You can notice this. So the denominator itself in your sixth problem has 2 raised to 3, 5 raised to 2. That means the factors consist of 2 and 5. That means it will be terminating decimal expansion. Then let's go for one more. That is your 7th. Let's see what it says. It says 129 upon 2 raised to 2, 5 raised to 7, 7 raised to 5. It has 7 raised to 5. But we know that in your denominator, if it is 2 and 5 factors only, then only we can say that it is a terminating decimal. It has 7 also, so we will say no, it is not a terminating decimal. Clear? So you got the point here. Okay, shall we pack up here? God bless.